let's add our component interface and the component containers. Hello everyone, this is Ali Reza. Welcome to the Mentor Code Lab. The component is just an interface. So I will add a new Java class that is interface and I will call it iComponent. And that's it. Basically, it's just empty interface. However, when you have an empty interface, it's far away from being useless. It's actually really useful. It's some type of tagging something without having overhead being added to it. So we can use that in many different ways. For example, we can have component container. Okay. Now component container will have a private final map of class that is unidentified, but we limit it to be the type of iComponent. You see how useful it is? And finally, the I component. Then we say this is components equals to new hash map. Now, if we extend any class from the I component, we can store it here and we can retrieve it. This single I component interface means that now I can have something like this, a Java class called test that implements I component. And as you see, I don't have to import any method or anything, but now I can have public Boolean some flag. And for example, public, I don't know, block, or I don't know, some class, some node, for example, some node. And this will become a new component that we can contain in a list. Cool, isn't it? Okay, now we have to have a way to add a component, get a component, remove a component, check if we have a component, then clear the component maps, and then get all the components, loop through them and stream them, and that's it. So let me add a new interface here, iComponent consumer. Now, if you are not familiar with consumers, consumers are functions that accept a parameter and doesn't return any value. So they just do their things on a parameter, and we need to bind it to iComponent. So we say void. Now we can call it accept or apply. Normally we use accept, and the T component means that, hey, if we have a class, okay, that is extending iComponent consumer, we can send a component as a parameter inside the method. The method will do whatever it needs and it will return void. That is the consumer type. Normally when you see consumers, we use them in lambdas, okay, normally. So as I said, we want a public T extends iComponent, add component, the class and T component. That's exactly what we need. We add a component of the type iComponent and the class type. So we can say this.components.put, for example, test component.class, comma, an instance of the test component. I will take this section because now we want to be able to get the component of a class type, and all we are doing, we say cast the result of the get from a map to our class type. Using class is a standard because it reminds people that they can use the class name.class. Then we have to have a way to remove a component. So public, that is void, remove component. Now the component here needs a class type of anything that extends the iComponent, and we call it again class. And all we are doing, we say just this.components.remove the class as the key. We want to check if we have a component inside the list or not. So we say public Boolean has component, and here again we are asking for the class. This time return this.components.contains key for the class. Then we want a method to clear the whole list. So public void clear. We call this.components.clear. Then we want to get all the components. So public, we return a map of class of type unknown that extends the iComponent, comma iComponent. We call get components, and this one just returns this dot components. Finally, we want things related to stream and for each. So we say public void for each. Now, if you are not familiar with streams, if you have an array, you can say array.stream. Then you can look through everything and say for each. This is how we use that, but exactly that's why we had that iComponent consumer, because here we want a consumer. So we say iComponent consumer of type iComponent. and we call it consumer. So all we do, we say this dot components dot for each. Now you see it asks for a by consumer. We want to send in a class, comma, component. And this is how you produce your consumer. Okay, so we say consumer dot accept, and you see this needs a component, so we send in the component. Now you may say that, hey, we didn't use the class. Yes, we didn't. Unfortunately, the for each is asking for a by consumer, means that a consumer that has two different inputs, and we are producing two different dynamic inputs inside that by consumer, and then we are doing our thing. Now here is the thing, we simply use our own consumer, and now we send in one parameter here. So basically what we are doing here is a two-folded lambda. One of them is not that much obvious because we are sending a consumer here, and the chances are that we will call it like this, for each, and we say component goes into do something. Okay, and this is our method. So we are sending a lambda like this here, and we are using another lambda here, and all we are doing is saying that, hey, get a component from components and then do something on that. Basically, that's how we are using this. Okay, we want a public stream of type I component, and then we call it a stream. We return this dot components dot values, and you notice that values is returning a collection, and we want to convert it to stream, so we simply call the stream, and that's it. We convert a collection to a stream. Now, what is the use case for something like this? We can say the stream dot, and you see that we have some things like map. Let me start from start. For any stream, we can find all matches, any matches, all matches. Yes, we are sending a condition, and we check that, hey, any member of this stream that matches this condition, please tell us that we are successful. Or any matches, if anything is matching this thing, then send a success. The difference is that all matches needs every member to match the criteria. Any matches, if we only have one member that matches that criteria, that's okay. We can close the stream, or we can collect some collection from the stream. As you see, we have two different ways. Then we have methods to call on that. We can get the count of the string. We can use drop whiles or equal, do some filtering, find anything in it, find the first element in it, and flat to different things, and do a for each again on top of that, that uses a consumer here, not a by consumer, but consumer. And then we can get the iterator so that we can iterate through it. We can map it. We can find the max and min if the comparison is possible. We can reduce from it. We can get the element and take it out of the stream and drop it after usage. We can skip some number of elements, then we can sort it. We can convert it to array or to list, and we can unsort it, and we can wait on it. Wait is on any object. So as you see, being able to convert a collection to a stream means that we can do some dynamic operations, comparisons, or filtering and things like that. It's the closest thing that I found to link in C#. If you are familiar with LINQ, link inside C#, the streams are the closest thing that I found to that. Okay, now we finished our component container, and we already have iComponent. iComponent consumer, you may not want to instantiate a class from it. Normally, you would use a lambda on it for the for each, but iComponent, yes, you will use that for your classes that should be component and can be used as component inside the container. Now, component container, normally I didn't add it to any of my block entities because the way 30 is using it, and I'm not sure if it's the proper way or not, as we saw sometimes I dissect his implementations, is that inside industrial block, he has these inventories. And when it comes to the block entity properties, he's handling the inventories directly as properties, because as I said, properties are the things that you assign at the constructor, and that's it. However, take note, when he wants to assign an inventory to the list, he is accepting either a simple inventory or an inventory builder. Now, we will dive into that, but inventory builder is just his own class that has a map of components. Now, component here is that I component, okay? Again, here's the thing. If you have this, why didn't you use the component container? Because that's the same thing basically. And then he has this Industrial Simple inventory. Now, Industrial Simple inventory has the component container. So basically, he's doing it in two folds. He's adding a component container to a simple inventory. Then on top of that, he is adding his own components to inventory builder. Honestly, I'm not sure, because when he calls on the build, he's saying, hey, return the inventory, and the inventory is the Industrial Simple inventory. He's setting the stacks on the inventory, then he is adding components to the inventory and returns the inventory. So what is the use case of these components? It's being used for the builder, okay? And basically, don't forget, this is a builder. Now, a builder for his own simple inventory, why is it sitting as an external class? Because normally you would have industrial simple inventory dot builder with some size, I don't know. Then you would call some methods on that builder, and at the end you would call the build and you would assign it as a industrial simple inventory. That's how builders are being designed. I will talk about it a few episodes later. However, the thing is that he's accepting the builder and then a direction. This is interesting. Builder here is not a static internal class. If we compare it to what he has for, let me find it first, industrial block, I think it's here, if I'm not derping. No. Oh, it's tick logic. I remember now. Where was that thing? There we go. You see that he has this tick logic builder. It's a public static final class, but his inventory builder right here is just a public class. So it's not a static final. The difference is that this guy has no constructor whatsoever, and this guy will have a constructor. Now, here's the thing. He's just assigning the size. And then he's saying this.inventory equals to new simple inventory block. So why are you doing things in two different ways? And consistency is nice in an API design. Honestly, I think I will convert it to a builder that is internal to the inventory. And here's a question. Do I want an inventory to have a component container? That's the whole thing. If you look at his wrapper class, now this is interesting because things are going for the next video, and at the same time we are brainstorming for it in a few minutes. So in here for the inventory, if you look at his wrapped inventory storage, you see that he has a list of inventories, he has a list of pair for direction and the simple inventory. So all he's doing, he's using a list of simple inventories and then a list of decided inventories and stuff like that. And he's not he's not using his own abstraction for this guy. If I go and find the usages on this library, you'd see that it's being imported inside the recipe input component. Okay. Then he has inventory builder, of course. Then the inventory builder, again, recipe input component and inventory builder. So how about this recipe input component? Where is that? It's inside abstraction component here. Okay, recipe input component. Are you being used anywhere? Again, just inventory builder. So as you see, it looks like he started working on a concept of a more complex inventory. And by complex, I mean more powerful inventory with the usage of iComponent interface. However, either he's working on it or he dropped working on it. The thing is that, as you see, it's just implementation of iComponent and recipe input. And if you recall, he has something close to that as recipe simple inventory, that is implementing recipe input. So this is a component that can be used inside the recipe simple inventory, and it's implementing the recipe input here and here. So get a stack in a slot. You see, he's tweaking stuff here and there. Basically, this is not a component. This is an inventory. This is really an inventory. And why do you have a public final inventory internal to a class that is responsible to give you the inventory compared to this guy? Why do you not extend it from, I'm not sure, your own simple inventory extension and then implement iRecipe and get done with it? Why do you need the iComponent implementation here? This is a class implementation. It's a component, okay? A component for recipes. Now, here's the thing. This is making me confused. The recipe input component is a component that will sit inside the component container. That's the main goal of it. And component container is actually being used here. So the component container means that a recipe input component, this guy, will sit inside his industrial simple inventory. And industrial simple inventory is an extension of simple inventory. Okay, then take note here. What is this? Why do you loop yourself? If this is a component that should sit in a list inside industrial simple inventory, then why do you have industrial simple inventory in the component? Do you want an inventory as a component of another inventory? I'm not sure if that's the case, then that's what you're doing, but there is a heavy payload being added to the header here right now. And honestly, I'm not sure if that's worth it. I'm thinking about any use case here, an inventory as a component of another inventory. You know what it looks like? You will have a chest, and each slot contains another chest. And in that second chest, let's imagine it like this. You will have a chest. One slot in that chest contains, I don't know, for example, a new type of chest, an iron chest. And this iron chest can have a slot, and this slot can have a diamond chest, and that diamond chest can have a slot, and this can go in and in and in forever, This is the concept that was produced by, I think, what was the father of Project E? I totally forgot that mod. God. Well, they had a bag that had lots of slots, and you could put another bag inside here. For example, think about a chest with, I don't know, 100 slots, and you can put another full chest inside this one, and that full chest has 100 slots, and this can nest forever. Okay, this is how this looks like. You are adding a full chest with, I don't know, 100 slots as a component inside another chest, inside another chest. I'm not telling that this is the case, but it's possible. The alternative is that you have a component container that has a chest in itself. And I'm not using the word input recipe component. No, it's just a chest. Okay, think about it like that. You have a component container that includes a chest, and you can use it in whatever shape or form you want. For example, if you want to, I don't know, bind it to a block entity, but then why won't you just directly use an industrial simple inventory? In my opinion, a component is something that is totally different. A component is a bunch of data that can be used inside your inventory, and it shouldn't contain another inventory for itself. God, I don't think that's the correct way of doing things. So the recipe input component, I'm not sure about this, especially not this part. And if you remove that part, then get a slot and the recipe input loses its meaning, and the get size loses meaning. So this whole thing is empty. So we will drop this. And finally, if you are adding this, and it's a nice thing to have actually, you have a simple inventory that has components, and you can call the mark 30 that is syncing component. Okay, now here are some things on top of the component. What is the syncing component? It's a block. Oh God. Now I think I understood why he has this. He is not creating a new block entity as a component. He's just referencing things. So basically he has a chest with a component that references the chest. Or I don't know, a component that references the block entity, because if we send the block entity as a parameter here, then yes, it will be a reference type. Okay, now things make much more sense. That's the proper use case for this. Yeah. Okay, it will call the sync on that. And this is the syncing component. So let's take a look. He says that in the inventory, when we are marking dirty, basically we are saying this, hey, if we have any component that is referencing our block entity, and if our block entity is instance of isync basically, then please find that reference to the block entity inside the components and call the sync. You know why I'm not sure about this? Because the way I implemented things, if you look, I have a sync method directly here, and yes, he should have that sync method directly on the block entity, but he's calling this sync method over and over and over from every inventory. And where am I using this for time being right now? There we go, inside tick. Ooh, this makes much more sense. So instead of going into each inventory and then finding each inventory and calling the sync on the block entity, hey, we are doing it already. We are calling the tick, and at the end of the tick, basically, before the update for syncing to the client or anything else, we are looping through every syncable and call it sync. And I don't see why you are doing it. This will happen each time you mark an inventory as dirty. If you mark an inventory as dirty, then it will go back to the block entity and sync the block entity and everything that is syncable on the block entity. Wow. Okay, this is interesting. So basically, he's thinking about a situation that we will mark an inventory dirty somehow outside of the tick method. Because if that's the tick method, then the tick method will sync everything. Okay, this makes sense for something like a chest because the chest is not ticking. Yes, this makes sense. Somehow we mark the inventory in the chest dirty without ticking. Okay, this is a must-have. Okay, this is a good one to have. This one means that we have an inventory. That inventory has a component, and we are assigning the inventory as a reference for this component, maybe because we can use it just how we used it right now, like so. So we can say this.component containers has any component that is a type of the class recipe input component. Then in that, call the method like get a stack in a slot or get the size. Why would I do that? I directly have that method in here, a simple inventory. I think, okay, we don't have those two methods here. Interesting. Actually, get a stack int size, into slot, that's the same, and the size. So yeah, we have it on the simple inventory itself. This one really makes me confused. I don't understand this one. I can understand this one, but why do you want to have the recipe input component when you have the same methods on yourself? I don't know. I think he was doing some things and then he left them as they are. Now this one makes sense again because it has a predicate and stack predicate component and then test. Basically, these are some replacements to what he has already. Recipe simple inventory, predicate simple inventory, output simple inventory, predicate inventory storage. Can insert, can extract, implements inventory storage. Interesting. Okay. Anyway, the way I see it, he was trying to replace what he has under the inventory util on a much more generalized and abstract way. Either he gave up or he is not done with it yet. So this looks like a working in progress to me, although it has its own merits. Don't get me wrong. One of them is exactly this. But being able to, okay, why not this? I can have recipe simple inventory extending this new inventory that we created that contains components. Why should I go with the way of having components instead of hierarchy of classes as inventories? I don't know. I need to sit back and think about this for maybe a day or two. But honestly, the component itself, the iComponent and component container, is a very powerful story. As you saw already, you can even assign your own block entity reference as a component to any container inside any object. And that's a nice thing to have. So that being said, I think I will implement that syncing or synced component because that's a nice thing to have. So let's add that one and get done with these. I will make a package now, component, because I'm not sure if we will keep these only two classes or things will change in future. So new Java class, and this is public class. Actually, what am I doing? The name is synced component. This implements the iComponent, and here we say private final. Now I will not start with my own classes because someone may send in something else. So block entity, and we call it block entity. And then private boolean is dirty. Then we want a constructor that accepts the block entity, and we say this dot block entity equals to block entity. Then we say public void sync, and then here we say if this dot block entity instance of I sync block entity, then we say if this dot is dirty and this dot sync block entity should sync what actually sync block entity. So wait a minute. Get properties. We don't have any properties because should sync is a part of the properties now. actually not should sync. What am I doing? Dot has world and sync block entity dot get world that is client. Now I know what's the problem right now. Okay, the problem is that, and this is calling the update. Oh wait, this is not syncing. It's calling update. What? Okay, let's change the whole thing. Really seriously updatable component. Now yes, because I know, oh wait, it's an update. Updatable BE is actually just a block entity that implements the update. So yes, I can now directly ask for, call it update, instance of, we don't need that. Now yes, we can go with updatable BE of any type. Then we ask for updatable BE of any type as our block entity. So we don't need that part. We don't need that part. We just go with this and we go with this dot block entity has word. Yes. If not, this dot block entity is client. And yes, I know. And then he's calling the update. This dot block entity dot update. Oh, seriously, the naming is so much different compared to sync component. Ooh, okay, that's that. Basically, I'm yelling at Turtle right now. Syncing component, then you use update on the sync method call. When you have a sync in your block entity, that makes things much more confusing when you are using your own API body. Be consistent with your namings. Oh, now this makes sense. Look, now this makes sense because now we know that it's updating, the client and server. Much better naming here. Okay. But the recipe input component, I still don't understand that one. Yes, you can have a component being bounded directly to anything, but normally we are working with block entities inside Minecraft. This is not Unity or Unreal engines. So we are working with Minecraft, and in Minecraft, normally when you have a block or a block entity, then you have inventories. If you have items and your item stacks actually should carry inventories, that's a totally different story. We will come back to that when we are handling backpack, and that's a very advanced stuff because the inventory is not sitting on the item itself. There is a huge difference there. Okay, so you need to be careful about this. If we have an item stack that somehow is bound to an inventory, okay, we can wrap this inventory as a component and put it inside our component container and assign it as a field. However, question comes to serializing and deserializing the MBT data. That would be a headache. Okay, so no, as much as I think about it, a recipe inventory, as he calls it, is actually just an inventory, and inventories have access to get a stack or get size, so it shouldn't become a component, at least in my opinion. At any time, if we want to, yes, we can add it, but unlike the update one, I don't see any use case. I can see the use case for the update. As I said, you have a chest. The chest is a block entity. It has an inventory. It's not ticking, so it's not syncing or updating. So you need to have it. You need to somehow call the update. Even for the inventories, if it's cited inventory and it's not ticking, somehow you need to call the sync. And again, that's another story for another time, because that would be synced tickable BE. Actually, if you want to, it's just something like this. Instead of update, you will have sync, and instead of updatable BE, you will have synced tickable BE. Again, if you take a look at this, there is a huge difference here between the synced and sync tickable, and that is the tick method. If we only have a container that should sync and update, I think we will have a synced BE in future. I will do it between the episodes. I will not code anything because this will make things confusing.
If you like these videos, please subscribe to the channel, hit the like button, and turn on that bell so that when I publish a new video, you will get informed. Have fun, everyone. Bye.